Good afternoon. Today we will introduce a new chapter on financial and economical analysis. I want just to remind you first of some concepts of economics. I think the majority of you have already taken some courses related to economics. So, just to revise some concepts, I will start with an example to remind you of the main, if you want, basic terms, let's say payback period, capital enrichment rate, what do we mean by internal rate of return, and then we'll go back into more details concerning economical and financial issues. So we'll start with a small problem to remember all of these concepts that we'll need in this chapter. So let us put the given. We want, let's say, to install a system to supply the needs of a small home, let's say. Okay, so you have, or a residential building. So you have a residential building, and you need to supply it with electricity. It can be a single story, and you can just have one home, or let's say just two floors. Okay, so you don't have a very large amount of power to supply, and you want to reduce using fossil fuels to produce electricity. You want to rely on a renewable system. Okay, so let's say you want to you have a zone where you have a lot of wind, and you want to buy a wind turbine that will allow you to supply your needs. So let us consider, for example, that we have to buy a certain turbine, and we want to study if this turbine, if getting this turbine is worse, and the price will be maybe high, and then you need to compare what you are paying now and what you will pay if you take this option. You can also say I have several other possibilities. So if we go to the design steps, we said you can rely on solar, you can rely on hydropower. If you have let's say a source of free water, or if you have a country where you have a lot of sun. So always you have several options. That's why you need to develop a decision matrix, put your options, and then decide. Okay, but now we'll go into detail in what type of analysis we can do economically to see if a project is profitable or not. Okay, so for example, let us say that for this wind turbine, the lifetime. So first we need to know the lifetime. So what is the number of years, okay, that this system will work? So let's say, for example, it's 20 years. Now, in the applications that we mentioned, we should differentiate between several aspects. We should, let's say, know if it's for a residential building, or also it can be, let's say, to sell electricity. So depending on the given, okay, you can completely change the project. You can have just a system to supply your own needs, and then your incomes, if you want, will be the reduction in your electricity bill. While on the other hand, if you want to construct a farm and you want to study what should be the selling price of electricity, then in this case you produce a certain number of kilowatt hour and you sell them to the community. So depending on if you want the owner, you will determine what are your incomes. Okay. So let's say it's a small project. We have a 20 years lifetime. We have the power. If you want the price of the turbine, for example, is, let's say, $4,000 per kilowatt hour. Okay. Or sometimes they give, in general, they give the selling price per unit power. Okay. And then you determine the energy produced by multiplying by the number of operation. So let's say depending on your needs, you say, do I need to buy a turbine of power 1 kilowatt or 2 kilowatt or 3 kilowatts? So it depends on the total energy that you need. Okay, so you can do small calculations for your design. So you say, for example, uh, first you ask the manufacturer, what is the number of hours of operation per day of this turbine? So you know that in general you need to have some time to have, let's say, to shut off your turbine, because if it will be always under continuous operation, this will increase the maintenance cost and this will reduce its lifetime. So maybe, let's say, they can tell you it's recommended, for example, to operate it, let's say, between 10 and 18 hours, for example, per day. Okay, so you can say then, let me consider the average number of hours for which I can operate my wind turbine. Let's say 14 hours. And in general, I can determine approximately for one day what is the number of kilowatt hour I need. So based on this, I divide the number of kilowatt hour needed. Okay, my need. So my need and number of kilowatt hour. I can divide it by the average number of operational hour, let's say here as average 14. And then I can decide then on what is the power of my turbine. Okay, so let's say, for example, we did the calculation and we found out that for our application, for example, we need a 3 kilowatt turbine. So this is the power of our turbine. And based on this, we can calculate then what is the price, what is the initial investment that I should put to buy the system. So let's say my investment will be equal to 4,000 times 3. So I need to pay as initial investment $12,000. It's already high. You know that if you consider your home and you say, I need to pay $12,000 now directly, I should be careful. I should ask myself, what is the time needed to get my money back? And after 20 years, what is the amount of money that I will save? So is this project worth to go through, or I should maybe try other alternatives, etc. So to be able to answer these questions, you should do your analysis, your financial analysis. So what is the investment? You should ask yourself, what can be the maintenance costs over the lifetime? What are the operational costs? So sometimes, let's say, if your wind turbine is not enough to supply your needs, okay, you need a backup system. So you can say, maybe I will not be able to completely get rid of electricity from generators, so I should then use also another backup system, or I can have, let's say, batteries that can store energy and give it me when needed, etc. Okay, so depending on your needs, or if you want the profile of electricity use, you can determine if this turbine is enough, or I should assist it with something else. Okay, so let us say that this turbine is fine for you. It will allow you to supply all of your needs, but still you should check if this investment is economically viable or not. This means if it will, at the end, it will give you profit or not, to decide if you replace, let's say, conventional generators that you have with the system, or also you can say, I will study other options. So you do, as we mentioned, you should put a decision matrix with all alternatives, several criteria, and to be able to do final decision. Okay. Now let us go into details. What can be the parameters, financial parameters that can help me to make a certain decision? So first we got the investment. Now, as we said, we should ask ourselves about maintenance. In general, whenever you buy a certain equipment, the manufacturer will give you idea about what are the maintenance needs, what should we do continuously, and what are the maintenance, if you want, guidelines, and what are concerning the corresponding costs. Sometimes you cannot do maintenance on your own. You need to get someone that has a certain experience in maintaining such systems. So you have in general some maintenance cost. So let us consider, for example, that for this turbine, they tell you nearly per year you need to have a maintenance equal to 3% of the initial investment. So the maintenance can be a percentage of the investment, or it can be a fixed amount that they provide you. And they can tell you you need $100 maintenance per year, for example. Okay. In general, the costs are given per year basis. So we'll use our analysis based on for each year what are the incomes, what are the costs, etc. Okay. So now I know the maintenance. All I have to do is to consider 3% times my investment. So which is $4,000. So I will get times, don't forget, times is 3, because we said that the power is 3 kilowatts. So you can directly say this is 12,000. And then you get that the maintenance cost will be equal to $360. Okay. Now, concerning the operational cost, so as we mentioned, it depends on if I need a backup system or not. If this turbine is enough for me, it will supply all my needs. We can consider that the operational costs here are zero. So I don't need, let's say, uh, to pay any money for electricity from generators, or I don't need I don't need, for example, some equipment to run my system. No need. No need for pumps. For example, let's say if you have a solar system, you might need to circulate water, so you need some extra equipments, or you need, let's say, to continuously have someone, a person, let's say, to operate your system, and if it's not automatic. So operational cost can be related to people that will take a certain job to function the system, or can be related to some, as we said, some, let's say, electricity consumption or external energy consumption that are required to run the system. Here, if the turbine is independent, it will supply me all my needs. I can consider that there is no operational cost. So for this example, operational cost is zero. And now I will start to get parameters that can help me into deciding if my project is worth to go through or not. So let us remember some important parameters and how to calculate them. So first, we have several important parameters. The first one is called the internal rate of return. It's IRR. Okay. Or in some books, they call it also ROI. Okay, depending on the reference, but it's the same thing. So internal rate of return. What do we mean by the internal rate of return? First, one very important aspect whenever you study a project is the time effect. Okay, if you ignore time effect, then you consider that the value of your money uh, will always be the same. Okay, and if I have money now or if I have it after 10 years, it's equivalent, which is never true. Okay, because let's say you have a businessman that is investing in a certain project. So first he will say, if I invest in project A, I can earn, for example, for each $1,000, for example, I can earn $200 per year, for example. So then, if I want to go into any other project, at least I expect to earn more. not less, because if I will earn less, I will not invest in option B. I will invest in option A. So the internal rate of return is related to the idea that the value of money is changing with time, and I can invest this money in a certain application and earn. So from a certain sum, I can expect to get a higher sum in future. That's why we say that first we need to define a certain parameter that will take into account uh, how I can invest my money. Okay, so you say, for example, let's say you have a certain private owner for this system. So the private owner of this home will say, I need to pay now $12,000. Okay, and I will consider that if I invest this amount of money in another project, what can I expect to get as return? So this will be the question. Okay, so let's say you consider that any amount of money, if I have $100 now, okay, uh, in 1 year, I expect maybe, let's say, to gain $10 each year. So this $100 will become equivalent to $110 after 1 year if I do a certain investment. So now, so let's say this is for investment A. Now, if I want to decide for my turbine, okay, so let's say for this project here, what I am expecting to gain. If I tell you for each $100 that you put, okay, you will be able to earn, so after 1 year, it will be equivalent to $105. You will say, no, why to invest this money here, not invest it in option A? Okay, it's right that I am gaining, but I can gain more. So the idea is that the discount rate can tell you, if you want, what is the equivalent value of money after a certain period of time if I want to compare it with a present value. Okay, so if you have a certain amount of money now, and you calculate what will be this amount after 1 year, in general, to be able to do comparison, you put all your costs at one reference of time. So let's say any value of money that you have, you say, I want to have one reference. I consider the reference is year zero, for example. Okay, so I from the beginning of the investment, this is my reference. I want to get all my incomes back to present in order to decide actually if it's worth to invest or not, because I should compare them with the initial investment that I consider. So if I have, for example, if I say I have an investment of 1,000, I equal to here $12,000. Okay. So as we said, we will be able to earn money because each year we'll have savings. So here, if you want, the earning money is not direct. If I'm not selling electricity in this application, I have two possibilities: or I put a wind turbine to sell electricity, or I put a turbine to supply my needs. So if I will supply my needs, this means that I will save money. So I can consider these savings as the net savings will be as income for me. Okay, so let's say you know that you will have net savings, and you will calculate these net savings. But can you consider them? How you will compare them? The net savings after 1 year will not have the same equivalent value for the same net saving after 2 years. Why? Because you need to project them back into present. Okay, or sometimes we project everything into future. The condition is to project to one point in time. Okay, so for example, here you say if for $100, let's say I expect to earn, so if I have an amount of $100 now, it will allow me to earn $10. So this means if I project it back to present, $110 after 1 year, okay, is equivalent, let's say, to $100 now for year zero. So to be able to make the comparison at one point of time, what should I do with this amount of money? I should divide it by 1 plus 10%, okay? So I can consider this is what we call the 10% is called the discount rate. This is what we call discount rate. And it will allow me, if you want, to determine what is the equivalent amount of money that I expect to have after 1 year. So $100 now will give me $110 in year one. And to know it will give me what in year two, I just have here to multiply by 110 by 1.1. Okay. While if I want to go back to present, so if I have this number, which is let's say my corresponding savings, let's say in year two, and I want to project it back to year zero, I should divide by 1.1 square, because when I go from year two to year one, I divide by 1.1. And then when I go from year one to year zero, I divide again by 1.1. Okay. So from here we say, whenever we want to express all money terms at one period of time, which is in general year zero, okay, I have to consider this amount of money divided by, so if this is year n, to get the equivalent amount at year zero, you divide by, so it's 1 over 1 plus a to the power the number of years that you have, the number of years. Okay. Now, as we discussed, the discount rate will depend a lot on the owner of the project. Okay. And for example, in general, a businessman will consider A as the market rate. So in general, in the market, for example, they tell you the discount rate in the market is 10%, for example. So if I am if I am a businessman, I consider that I should consider this value of discount rate in my analysis. Plus, we'll discuss after that sometimes any businessman can divide its capital into two parts. You can have your own money and you can have debit. Okay. So of course, the discount rate value will be affected a lot depending on the source of your money. Because if you are taking a loan from the bank, for example, then the discount rate will be equivalent to the interest rate that you should pay for the bank. While if you are using your own money, you say, if I use this money somewhere else, what I am expecting to gain. So if you invest in your own money, then you can consider a discount rate that will be comparable to other projects that you are investing in. So already you are investing in some projects, for example, you are doing some income, you know what is the amount of money I expect to gain. Based on this, you can select A. And we'll see in detail sometimes that you can have just percentages. So as I tell you, you are using, for example, 60% of your own money and 40% as debit from bank or loan from bank. So you can just consider the difference between the two. You need the percentage for each, and for each one, what is the corresponding value of discount rate. And you can take like an average weight value. So for example, if we take an example, let us say for if you take a loan from the bank they tell you the interest rate, for example, is 6%. While if you are investing in the market and you are gaining for, let's say, each $100 will allow you to gain 10% of its amount each at the end of each year, then you say, since I am investing in my own money, I will consider the market rate, which is, for example, A equals to 10%. So then you need to know how your money is divided. Let's say 60% from your own money and 40% from debit, or you are taking a certain loan from a bank. Okay, so you just have to consider the total value of your equivalent rate. Okay, so overall A is equal to 0.6. So 60% times 10%. So 0.6 times 0.1 plus 40% times 6%. So plus 0.4 times 0.06. And in this way, you can determine what is your discount rate. Okay. Now, what is the internal rate of return? To be able to understand the internal rate of return, we'll discuss first what is the net present value of a certain project. Okay, so here, if we go back to our example, we got the value of investment. Okay, so the value of investment was $12,000. Now we need to know all costs and all savings. Okay, so we said that the investment is known, the maintenance also is given per year. So each year I need to pay a maintenance cost of $360. Now I should ask myself, what are my incomes, or what are my savings? So if I want to sell electricity, let's say, okay, I need to know what is the selling price of electricity. And in case I want to replace the electricity from generators, I should ask myself, what is my bill, and how many dollars I am savings by operating my wind turbine. So here we need to know the number of operational hours. So as we discussed, it was recommended by the manufacturer to have an average operating hour of 14 hours. So we have 14 hours. So this is the operational hour per day. Okay, operational hours of the turbine per day equals to 14 hours. And the power of the turbine is known. We have a turbine of power 3 kilowatt. So now we can calculate per day what is the amount of kilowatt hour that that my turbine system is able to produce for me. Okay, so I can say that for one day, I can produce with my system 3 times 14 kilowatt hour. Okay. Fine. But since we are doing the analysis per year, so the maintenance cost is $360 per year, then I need to determine, okay, what is my savings? So my savings, if I am putting a system to my own needs, I need to consider my savings. My savings constitute my income, because I don't have to pay electricity bill anymore. So I am gaining money. So my savings are the number of kilowatt hour per year. So let's say we consider 365 days per year. So I should multiply 365 times 3 times 14 times what? I should multiply by what now to get my savings? So when I do this, what do I obtain? 365 times 14 times 3. I obtain the number of kilowatt hour that I am using from my turbine per year. And if this turbine was not present, I should buy this electricity from another resource, let's say from generators. Okay, so I know what is the price of 1 kilowatt hour. So I should multiply by the selling price in dollar per kilowatt hour. So let us consider, for example, okay, that the selling price is, let's say, $0.1 per kilowatt hour. So I can compute my savings for each year. Okay, so I get that I am saving per year $1,533. So $1,533. Okay, now once I do this, once I know per year what I am saving, I can start to get the most important parameters that can help me into doing my assessment, my financial assessment for the project. Okay. Okay. So we discussed the time effect. Let us consider, I don't want to consider time. Okay. If I don't want to consider time, so I consider that I cannot do anything with my money. I cannot invest it somewhere else. I don't want to put it in a bank. So I will consider that there is no discount rate. So the value of money now or after 10 years is the same. But of course, it's not a good way. You know, it's not a good analysis to not consider time effect. But sometimes not considering time effect will just give you a rough estimate. Okay. For example, you know already that if you don't consider time, the payback period will be much lower. Okay. So in case, even if you don't consider time, you get a very large payback period, you can stop here. You can say, no need to do any further analysis, because if I don't consider time effect, even with this big assumption that is not true, I am getting a really large payback period. And I can calculate my corresponding savings. If it's not large, I can stop here. No need to do further analysis. So it's true that time effect is important and we never neglect it, but why we calculate some if you want characteristics without considering time effects? Because they can be they can give me some indication if I continue the analysis or if I stop here. What I mean by this, okay, for example, I can ask you now, if you don't consider time effect, what is the payback period of your system? So we call it non-discounted. So it's a non-discounted, yani I am not considering any discount rate. So I'm not considering that the value of my money will change with time. Okay, so non-discounted payback period. Whenever they ask you to get a non-discounted payback period, this means what is the number of years that you need to get back your money. So here you invested, you put at year zero $12,000. After how many years you can consider that I was able to have back my money and I will start to gain? Then it's very simple to find it. It's a very simple mathematical equation. I say my investment is 12,000. So minus 12,000. Now, for each year, okay, what is my net income for each year, I will gain the difference between my savings and my maintenance. So it's 1533, which is the amount that I am saving per year, minus the maintenance, which is $360. And of course, here I am assuming